me see that's going to work. Okay. All right. Yeah. Great conversation. This whole application versus, data is really the word, I live in, as well. And I came from Siemens Digital Industry Software, where it was all about applications, and connecting those applications and the hurdles, you may have, with this. So I'm really, excited to be able to be here today to talk about how we can really, address this data problem and do it really well, in combination with HighByte. All right, let me see. Okay, so the first thing I want to talk about is actually something from Jeff Bezos, and which is, we know a lot of things are changing, but actually the way Jeff Bezos looked at that for our company is also what is not going to change. Because that's going to be very important as well to keep this in mind and keep your focus on, so that you can really build a very sound strategy, business strategy around this. And coming back to the way I think HighByte was born and how AWS was born, I see a lot of similarities in terms of like some of those things are not working, for people. So at the time when AWS was born, it was really related, and you can actually read this from ND Jassy. There's some laters, that relate everything that happened. It was really about how at the time, it was back in 2000, the Amazon, e-commerce site, like merging with Target. I don't know if some of you may have used at the time. Same password, username and password were being used at that time. And but the application was good, but it was good not for one specific need, at the time that was needed for Amazon. So that's when they decided, is like, well, we don't need an application. We need to go back to primitives. We need storage. We need compute. We need all of those different pieces that are very, very good at what they do. And then you can pretty much build anything you want, right? So again, it's kind of like that mindset, as we look into this and as we focus on what really, really matters, in this case. So when it comes to manufacturing, what we're looking at is what is not changing is making sure, obviously, that you reduce variation as much as possible. You want to be as consistent as possible to have the highest availability, performance, quality, inventory, etc. So you really want to make sure that you're going to be predictably boring, like one of my colleagues used to say, and he used to be a plant manager. The other thing that is very key here that is not changing is empowering employees. And, this is what I really saw. I was at the Tulip conference the past 2 days, and it was very, really, really interesting to see how Tulip is really at the center of making the operator's life, better, from that perspective. And it's not only important to like make it better, making them make decisions faster, but also coming back to what Sebastian was saying earlier on, which is the knowledge, right? Like we're losing this knowledge, as well right now. So we need to make sure that we can retain that knowledge as much as possible within the company, and also train, new like onboarding, was a point that was made earlier as well. That's very key, as well. And the last point I want to make is about adaptability, which is really speed, right? We know a lot of things are changing, technology is changing, but you still need to have your business to be very flexible and adaptable, to be able to respond, to these. And the key question, even for us when we talk to our customers is like, especially right now, it's all about, AI, Gen AI, Gen AI. Okay, but does I really need to use Gen AI? We do see customers coming to us and say, I need Gen AI for this. And then we're like, no, you don't. There's a technology already that exists that you can leverage that is not Gen AI. So it's really about, does the technology make sense, right, for your business, and we always look at it from that perspective, at least from my side as well. It's like coming back to use case, coming back to really answering a business, problem, and addressing this. So now I want to talk about what is going to change. And here's the ISA 95, right? So that's that monolithic, kind of pyramid. And it's really, highlighting how you go all the way from, obviously from the sensors, data, all the way up to, ERP, and how you have to go across those layers, in a hierarchical way, and how those, again, applications, right, have to connect to one another, creating quite a bit of friction. what we're seeing today, we talked about that already, for the past few hours, is how that's being deconstructed, right? And the first reason is the cloud. That really revolutionized IT, from that perspective, and moving a lot of those three-letter, systems, PLM, ERP, etc., to the cloud to get that data more readily available. But we're also obviously seeing this at the shop floor level with more descriptive, protocols, being used, as well. And what we're seeing in the near future, and obviously with, this is where like a solution like HighByte will be very key, is how this is being even more deconstructed and potentially providing access for data from the PLC all the way, potentially to the cloud, right? From edge to cloud, and being able to do, analytics, and prescriptive, predictive, on the top of that data, to the point of we are envisioning what we would call a smart software-defined, factory. All right. So this is where really industrial data ops, comes into play. And I cannot obviously talk better about this, than what, John was doing, before me. Ultimately, but what I wanted to show on that slide is why, it's so complicated, right? If you look at a pump, you can see a lot of information. There's all the data properties, the type, the function, like kind of like the fluid being, used in that pump, transactions. You have like the 2D drawings, etc. So a lot of information, which are very meaningful, but to a lot of different types of people and personas. So someone on the supply chain side, they obviously want to know, how long it's going to take to replace, this pump, for instance. But an operations engineer may want to understand when that pump might be failing. So this is where it's really important to have that data, but to make it much more visible so that everyone, from top floor to shop floor, can actually leverage that data to do their job, right? And this is where that challenge of creating that semantic data model that will store all those relationships, but also maintain, these relationships as the assets and the sources of the data are changing, is very, very key to really be able to deliver on those business, outcomes, all the way at the top floor. So this is the way we do it, like at least the way we see it at AWS. I'm just going to go through this. So first of all, there's the data obviously at the shop floor level, with like sensors, like SCADA, Historian, etc. Now, what we've seen, from the cloud perspective is a lot of those applications as well, from MES perspective, QMS, etc., are being moved also to the cloud. And that's allowing, that information obviously to be more digestible and visible. But then what you have as well is a way to connect that, right, with the data coming from the shop floor or everything that's at the edge for the industrial DataOps. And what can be done at that level, through the cloud is to do more contextualization using a knowledge graph database or even vector database, depending on structure and unstructured data. And from there, this is where obviously you'll be able to add analytics, Gen AI agents to be able to do more decision and more automation, as well in your processes. And all of this is being done ultimately to really be able to deliver the digitable composed outcomes. We talked about use cases, and this is where, they would really fit in terms of like production management, quality management, and ultimately, again, being able to drive your factory from a software, defined, level. Now, the way we do this is obviously a combination of AWS services, obviously that, go across, those different layers here, but also we work very, very closely with partners like HighByte, like Siemens, like Rockwell, etc., and also that integrate, right, in that ecosystem that I'm showing here. And we also work a lot with OT integrators, like a TCS or like also SoftServe to be able to help with implementation, for all of those different technologies. Okay. So it's great to look at this, and it looks nice and well in theory, but how does it work, right, in practice? So this is what I want to jump into now when it comes to experience from two of our customers. But before I do this, this is kind of like an example of like a high level, I would say, architecture, what it could look like with the ingestion of the data from the different systems, that we've talked about, ignition or like from the Kepware side for the different time series and so on the telemetry aspects that would go into a HighByte. And then from an application, level, like John mentioned before, when it comes to like MES data and other of the systems. So that data would be ingested, with HighByte and contextualized, from there, as you just saw. And after this is where the UNS, architecture could also get started, either through one of the broker here that is directly accessible from HighByte, or there's also a namespace designer that comes out of this, and the data can then go to the cloud and different type of services that we have available here. We mentioned, we talked a little bit about storage earlier on, so you can see here they could go to an S3 bucket, so then it can be moved over to a Snowflake or Databricks or any of those storage platforms. Other ways to do this, depending on, again, what kind of use case you're trying to solve, would be to go through a site-wise or an IoT core. When you look at the IoT core aspect, it kind of like also can be used as an MQTT broker, and from there, maybe do machine learning, work. And this is like an example I'm going to talk about, in a few slides. So the one customer I want to discuss first, and the HighByte team knows that customer very well as well, is Vivix. So Vivix is a Brazilian glass company. And back in 2021, they were looking, they were really growing, quite a bit. And as they were growing, they realized that they were really not ready, from the data strategy perspective. This is the way they were doing most of their work, is through Excel spreadsheets. And the data was manually entered in SAP. As well. So that was not sustainable as they are really growing, their footprint. So what they decided to do is build like an industrial transformation, team. And from there, they defined multiple use cases, and they defined, what the data then should look like. That data flow, right, should look like to be able to address those use cases and actually get the outcome, they were looking for. And it's really back down to a data-driven, strategy again, because as you can see on those use cases, you see the data is very key, production management or like water waste management, or like some of those are really going into process control. So again, those temperatures, the pressure, all of that very detailed data has to be, taken out, right, of all of those systems so that then it can be contextualized, and then you can actually put that analytics on the top and make those decisions, that will be important for the business. The one I want to talk about a bit more is that glass DNA, which is product traceability and genealogy, because as Vivix built this, which is really where they had all that production data, they also had like quality metrics and some operational insights. They also realized that their technicians were taking a long time to be able to repair, right, on the shop floor, and therefore they ended up putting a virtual engineer application on the top of that, so that it could go and sync, at the time it was a chatbot, so it was about a year or so ago that they did this. I think now they're going more into an agentic, approach, but the goal here was to be able to really find that information quickly in terms of like, okay, what kind of defect was this? So that you really realize from the defect, it might be coming from this and from this, right? So really tracing down like the root cause and being able to right away understand how to fix it. And by really setting this up especially for the new engineers, they could then come up to speed, being trained very quickly on the job. I think it cut some of the training from like a year to like a few months or so. And the other thing was decreasing, the time that was taken to search for this and to interpret the information, as well. And so that's something that was very important for them and was very impactful, I would say, for them to realize. Now, how did they do this behind the scene? Well, this is the way the technology, right, comes together, and the partnership, I would say, that we have at AWS with HighByte and a few other partners here that made that possible for Vivix. As you can see, in 2021, it started, with just historians, right, in place. And as they're moving forward, you can see that kind of stack, right, I was talking about, from the data from the shop floor all the way going up to that top stack, which is that composable, application. As you can see all the way at the top on the right-hand side, like the Mendix, application, which is a Siemens product, which allows you to really build different types of applications that are very dedicated to specific use cases. And below that, this is where, you can leverage, in this case, like a Bedrock, which allows you to call in different LLMs. For the virtual engineer I mentioned, it was using Claude, for instance, behind the scene to build this as an access to Mendix. And you can see, the usual suspects here, like a Snowflake, for some of the data storage, and, going all the way down to HighByte, for that data, like exposing that data, contextualizing that data, and all the way down to the PLC level. So that really allowed, in this case, to do that unified IT and OT data products, and that collaboration. As I mentioned, now the company is really set, and ready to go as a foundation for the generative AI. I would say empowerment. From that perspective, it's kind of liberating, that aspect. All right, another example I want to talk about is Gousto. And so Gousto, I think most of you, I don't know if you know Gousto, it's a UK-based company, but it's kind of the equivalent like Blue Apron or HelloFresh, I think, in the US. And so they were founded in 2012. And when at the time, they were like putting together like 5,000 boxes, like lunch boxes. And they scaled so fast that they had to automate this to be able to deliver 200,000 boxes a week, which is one box every 3 seconds. So they had some pieces in place, as you can see here, some equipment, some PLCs, they had Kepware defined as well for the PLC server. But that was pretty much it. And the problem they had is they realized that their availability was too low. And it was varying. It was between 70 and 85%. And they didn't know why, it was varying. So because they didn't have access to the data, it was still kind of buried, at that level. So what they decided to do is, implement HighByte. And, being able to take that data out. And by the way, what's interesting in their case is they tried to build an equivalent of a HighByte themselves, and they failed. They completely failed. And they actually, recognize that. And when they use HighByte, they were able to actually, expose that data like within 2 days, as far as I remember. So big impact, for them. And from there, they were like, well, okay, now we can maybe better understand what is going on in terms of maintenance. We know that availability is pretty low. What is happening, exactly in our organization when it comes to maintenance, for a particular system here. And as that data got exposed, they realized that, they had they uncovered new patterns of like defects, and for their maintenance. So they changed, their maintenance plan accordingly. And originally, as they moved the data into AWS, through a IoT core here, they were doing like more reactive maintenance, in a sense like, they were detecting the default. Okay, I'm going to open a work order, and there's going to be a ticket for maintenance. Fine. But now that this data is available, how about we move into something a bit more predictive, which is, okay, now I have all that history, of maintenance data, and maybe I can actually, and how the asset might be behaving. And from that, I can go ahead and maybe train a machine learning model so that I know as I'm running my operation, my asset, I can see trend. And if that trend is changing, well, now I'm going to trigger, an order so that, okay, I don't have to wait for this machine to fail. I'll be able to go ahead and say, hey, you need to go and look at this machine because it might fail very soon. So let's go ahead and fix it. Okay. And that was one of the first use cases they did, but obviously that's not the last one. So now they've been, looking at adding more areas of interest, I would say, that they need to focus on, like product optimization, schedule optimization. Now that the data is available, like the sky is pretty much the limit, right? But obviously we have to come back to, those options like that we talked about earlier, which is what is not changing, right? And making sure you have the highest efficiency and you can optimize your production as much as possible. So ultimately, they'll be able to build a factory twin, right? That's where they're going with that, which is, we talk a lot about digital twin, right? Digital twin for the real time, operations. But then as you have, all that data, you can build a twin that you can stress test, potentially. So to understand, and this is what we do at Amazon, by the way, in our fulfillment center. We do have a twin, of that fulfillment center. And before like Prime Day, and then other where that this is going to become, pretty, you're going to have an increase in capacity, you can stress test the system and see potentially what may happen, right? All right, so let me see. I think I'm almost done. What's next? Well, obviously, it's all about AI, right? And what we've seen at Amazon and AWS in particular is how obviously ChatGPT changed a lot of things. And then in 2023, we had a lot of customers coming to us wanting to do a lot of proof of concept. It was all about proof of concept in 23, right? And playing with GenAI, chatbots, etc., you name it, right? So to try to automate a lot of the repetitive tasks. In 2024, we've seen more of those POCs become real life, examples and being deployed in production. On the engineering side about, mining engineering knowledge, again, to accelerate, that decision making, I would say that people need, right, to be able to be faster, and remove those repetitive tasks that are not really, producing anything, for the company, in this case. And now we're seeing more like agents, right? So instead of having that chatbot, now you actually have an agent that is defined that is doing, those tasks. And you could have one that is very top of mind right now for customers is an RFQ. Doing an RFQ agent. It's like you have an agent that actually is going to run potentially other agents to be able to take, an RFQ coming in and you respond back, and all of this is automated, going, searching the data to bring it back together, much faster. And that's really where we're in 2025 with the agentic, AI systems, where now you have more autonomous, agents. There are multiple agents working with one another. And it's not just automating this, but it's also making decision, about this and actually moving again, this, decision making, faster. So I have here 3 cases. I'm going to go quickly because I'm probably running out of time. This is what we're seeing as the top manufacturing agentic AI use cases, right now. And when we say manufacturing, you see the first one is more on the R&D, side. But obviously, being able to do more research, intelligence, and discovery is where you'll find, some of those agents. On the maintenance side, when I talked about how it goes into right now, machine learning model will go or see maybe there's a trend. It could actually trigger, an order. All of this could be completely automated. And this is going in the direction of almost a self-healing, behavior, which means that even a human may not even know that something happened, in this case. You might be aware, but if everything got fixed, automatically, then it doesn't matter. Your production is continuing. Everything is being done, according to plan. And the next big one, actually on the on the shop floor, I'm seeing a lot of agents being implemented for production planning and scheduling, as well, is another area where you have that. And finally, on the supply chain side, that's a big topic, but being able to do more optimization of supply chain, is where we're working, closely with customers, as well. All right. So, just to summarize here, happy to answer any questions or, if you want to come and talk to me, but I really wanted to emphasize how AWS, plays a role in the bigger story of data and also, being able to then add intelligence, right, to that data and the decision making. Thank you.
Yeah, I think of the maintenance, a couple questions on that. What CMMSs were being used? I'd be interested also in the FedEx case, if that can be shared.
The FedEx,
and then,
I don't know.
And then I guess the second part is self-healing systems. Where are you seeing that? Because I'm thinking more parts where, at least traditionally, for things being messed up. I mean, certainly there's chemical concentrations that could be self-healed, but okay. I mean, typically machines breaking, I don't know how.
Well, it's not breaking.
Yeah.
See, the point is actually you actually fix before it breaks, right? So what happens is with the machine learning model, you'll be able to keep track of the trend. And if you see a slight deviation, then you're it's not breaking yet, but it's giving you a signal that it might break soon. And therefore you actually it triggers an order so you can go and get someone to do this.
I see. So somebody else is still...
Someone is going to have to fix this, right, before it breaks. But the whole point is to actually do it before, it breaks. Which is why it's a predictive and then prescriptive thing. Here, now you have to go and do this. Or an agent could actually, say that, saying, oh, you have to go and fix this, but it may not be a human. It could be an agent going potentially to another agent saying, now you have to go and trigger this. And then it triggers an order to go and, fix the machine, as well. But I'm not saying that the human is not in the loop, right?
Yeah.
A human may still have to do the work, but it's not necessarily a human in this case that may do this whole chain, of events.
Yeah, I mean, I guess and it could be just because from being from the wrong industry, I'm still somewhat skeptical of a lot of the maintenance things, and I'd be interested if anybody else in the room, because it's oftentimes you have temperatures that are indicating that the part needs to be worn, and you don't necessarily need AI to figure that out. You more just need to be able to read the temperatures. But are people seeing things where some is 103 versus 107, and so now they know to go see it earlier. I'd just be interested in more details on use cases. Maybe it's out of the scope of this.
Yeah. I mean, what we're seeing there. So I'm trying to think about some of the predictive maintenance, the industry where I've seen those being defined. John had earlier Georgia Pacific, so it's a paper company, and they've implemented this. I think they had a machine. It may not be them. Another paper company I'm thinking about, they had an issue with the thickness, of the paper. And then, in this case, you could actually they put an infrared camera to recognize that it was not the same thickness anymore. And therefore, before it was too late, they saw some signs and then therefore they would, stop it before that. So these are some examples. I can send you more examples in what industry are you in? You said?
Electronics.
Electronics?
Yeah, so PCB specifically.
Oh, PCB. Okay, so, yeah, I can certainly look into that because
defense, aerospace. Yeah.
Yes, yeah. No, I do. I think have example on that. We had one recently with a connector, company where they were looking at some of the stamping, going on for them, and so they were developing, machine learning model to be able to predict that, as well. But it's more than just one parameter. I would say, to your point, just temperature, it's usually more complex, than that to be able to do it.